Hello and welcome back to another video in this Java tutorial series. In today's video, we're going to be discussing a new concept called methods and how it fits into this idea of object-oriented programming that we talked about in the last lesson. Now, before we get too far into this, what you can see here is that I've copy and pasted our car.java class from our lesson 4 project over here to our lesson 5 folder. That way we can take and modify this file as needed for this lesson. But if you'll remember from our last lesson, what we talked about was that we could take these instance variables or these 4 individual containers and we could package them together into what would be a singular car object. And so we take the model container, the year produced container, the make container, and the color container, each of these individual containers, and we would package them up into what would be a specific car object. And so what this car object would let us do is it would let us be able to treat these 4 different containers as kind of this single combined object that would represent this singular car here. And then we could also use the constructor here provided in our car class or our car blueprint to then modify some of these these default values that we had here for our instance variables, allowing us to customize these containers specific to each of our cars here. It is also important to remember from the last lesson that this car.java class is also just a blueprint. It just tells Java how to create a car object. It just tells Java how to assemble 4 containers into a car object that kind of act as a single object. And it uses the constructor to help assign special values or unique values to each of those containers. But the car.java class here, or the car class here, is just a blueprint for creating a car. So when we go and we create a car object using our car class here and using our constructor, when we create those objects and we tie together those containers, because the car class is just a blueprint, the values aren't stored in this car.java file. It goes through and it creates four new containers that are wrapped together into our red Ferrari 812 GTS. It is 4 unique containers that are encompassed and smushed together into a single red Ferrari object. When we go through and we create another car object, it uses this blueprint to create another car, and it does the same thing where it takes 4 new containers. This is the important part that you are going to have to remember for the rest of this lesson, is that it creates 4 new containers separate from the 4 containers used to create the red Ferrari, and it wraps those 4 containers here into this now green Ferrari object, and it gets stored in this green Ferrari container. But these are, each time it goes through and it creates these new cars and these new objects, it is taking these 4 containers and it is creating 4 unique containers specific to that object. And so these 4 containers here for this car object are completely unique from the 4 containers wrapped together to create the green Ferrari object. And to really prove all of this to you, what I can do is I can actually print out these car objects. And if I go sysout and I print out the my red Ferrari object, what it's going to do is it's not actually going to print out like the brand to assign, the model to assign, the year produced, and the color. What it's going to do is it's going to print out the memory address of where these 4 containers are stored for this object. That's essentially what it's going to print out. So if I run this, what happens is we get this random memory address here, and this is just some place located somewhere in your computer's memory, which is storing the location of these 4 containers that basically make up your car object, because it's these containers that essentially represent what your car is. And if I go through and I print out instead the my green Ferrari object, so if I go sysout and I print out the my green Ferrari object, what we get is a different memory address because these containers here related to the green Ferrari are stored in a different location from our red Ferrari because they are two unique cars. The containers related to each of these cars are completely independent. And if this doesn't make sense, I encourage you to go back and watch the lesson 4 video because up until this point, this is all just review. I will also real quickly state that the code I just used for that example here, I just created two new objects here that represent a red 812 GTS and a green one. And it still just uses the same car.java class here that I have defined over here in our lesson 5 folder. So we're not doing anything new yet here. I just created these two extra objects and I was using those for the example. So now that we've got the review out of the way, we can finally get to methods. And so what methods are the kind of two ideas here. And so the first is that methods are actions that our objects here can perform. Our red Ferrari, if you think about it so far is only been described by its characteristics. So the brand, the model that you produced, and the color only describe the car object's existence, its physical existence. But we haven't been able to make it do anything like drive around. Just like we're programming a theoretical car here with our car class, and it can't perform any actions. And this is where methods come in, is they allow our car objects. And remember that when I say a car object, it is really just kind of this combination of the containers here, these instance variables wrapped up into a car object. So it's this the combination of these four containers here. But it is just an action that this car object here can perform. And so the second part of this is that action has to come with some set of instructions. And so this set of instructions is going to be in Java here a block of code that will run when a method is called. And this probably doesn't make a whole lot of sense yet. So the fastest way to get into this is to give you an example. So over here, what I have is a description of all of the things that are necessary to create a method. And so I also over here in this help folder have a method cheat sheet, and you should be able to open this up. And if you can't, you might need to install an extension called draw.io integration. This might be necessary. I don't know for sure or not. But what you can use this for is to kind of look back and see, oh, what are all of the necessary things here in order to create here a functioning method. And it kind of describes all of the different pieces here. But the first thing that we're going to need here is what is called a return type. And this just tells Java, hey, when we call this method at some point, do we want to send information out when the instructions to this method here are finished running? And if we do not want to send anything, we use the return type void. And so that's what we're going to do here for our example drive method. And the next thing we need here is our method name. And in this case, we're going to just call it drive. And then we need a set of parentheses. And within these parentheses are what are known as the parameters. It's the same thing that we had with our constructor. And so this is going to tell Java, hey, does this method require us to send in any information for us to use within our method? And so if we were to put a string container like brand to assign or something like that here within the parameters, this method would now require us to send in some string that would get stored in this brand to assign container here in our method here whenever our drive method is called. But in this case, we don't want to send in any information, so we're going to leave these parentheses empty. And then what we're going to do is we're going to list out these curly braces, and these curly braces are going to create what is known as the method body. And it is here between these curly braces, or the method body, that all of our instructions go to carry out the action of being able to drive. And so for this very simple example, we're just going to print out that the car is running, or that the car is driving. So we're going to print out the car is now driving. And we'll put an exclamation mark. And so this is a very basic method, but it has all of the components that are required. It has a return type. It has a method name, which is drive. It has parameters, which in this case are actually empty parameters. It has the curly braces, and it has the instructions that are required to carry out the action of driving. Now, if we go back over here to our main.java file here, what we can do is we can actually now have our objects perform the actions that we just defined. We just defined this drive method or this drive action, and now we can make our car objects, our red Ferrari and our green Ferrari, we can make those objects now drive. And so if we come down here, what we can do is we can take our my red Ferrari, and then we're going to use that dot operator like we did with accessing the instance variables that were tied to these objects, or the characteristics that were tied to objects like the brand, the color, and the model in the year produced. And now instead of listing out the name of the containers that's tied to it, we are going to list out the name of the method. We're going to list out the method name here. And so, or not, sorry, not method name. We're going to list out the drive name here. So we're going to list out drive, and then we're going to put those sets of parentheses. This is where we would pass in information if we wanted to send information into our method. But because our parentheses here are empty, or our parameters are empty, we are not going to pass in any arguments here to our parentheses here. And then at the end, we just need to put a semicolon. So what this is going to do is it's going to take our my red Ferrari car, or that set of 4 containers, or that idea of a car that we have created and packaged together, and it's going to perform this action on that car. And so this isn't going to actually interact with any of the characteristics of the car. It's not going to influence any of these instance variables that are tied to our car objects, but it is going to print out the statement, the car is now driving. And so if we run this method, or we perform this action, it's going to come down here and it's going to carry out all of the instructions that come with this action here. And so what we get is we get the result that the car is now driving. And that's the print statement that we had here in our drive method. Now, something really, really important to remember here is that this method is still a set of instructions. It is still just a block of code that will run when our method is called. This is all that these methods are. Is they're a set of instructions, or they are blocks of code that will run when we call it. And I simplify it down with this idea of actions and instructions, because this helps us to represent more complex relationships using words that make sense in other contexts. But at its core, it is still just a block of code that will run when a method is called. And so when we call the drive method, it's just running this block of code here that is listed here in the method body of our drive method. And so if I go here and I actually call it again, and if I call my red Ferrari dot drive, and I list it out again, then because it is just a block of code that will run when it is called, it's just going to come back over here, and when I call it again, it's just going to perform this same set of actions when I call it the second time. And so we get that print out statement here twice. Now, because we've defined this drive method here in this car blueprint, and because all it is just a set of instructions that a car object can carry out, we can actually call this same method here on our green Ferrari as well. So if I come down here and I print out my green Ferrari dot drive, and I can actually just get rid of one of these calls, then what we still get is we still get the 2 print statements. And that's because when we call the drive method on my red Ferrari, it goes to the definition of the drive method here, and it carries out the actions related to this method here, or it carries out the instructions here in this block of code. But because this drive method is tied to the blueprint of a car class, these are actions that all cars can perform. And so because my red Ferrari and my green Ferrari are both cars, then they should both be able to perform this same action. And so up until this point, everything here has been pretty simple. We haven't been doing anything very complicated. We've just learned how to define a method and how to be able to call that method here with our objects. But the real power here of methods and their role in object-oriented programming here is that because they act on these objects, they can actually access the information that is tied to that object. And so what we're going to do is we're going to create a method here that's going to take one of our red Ferraris, and it's going our red or a green Ferrari, and it's going to take that car and it's going to change the color associated with that car. And so we're going to go over here, and I have it basically already written up here, but I'll kind of explain this as I go. But we have a void return type because we're not sending information out anywhere. So we're going to list up void. The name of the method is paint purple, and we are not sending in any information. So empty parentheses, and then our curly braces to denote the method body and the instructions that will go with this action here. And so here within our method body, we are going to list the instructions required to paint our car purple, or the code that is going to run when we call the paint purple method. And so we are going to take the instance variable color, and we are going to take it and we're going to assign the value stored in that color container here with the value of purple. Now, if we call this method on one of our cars, so if I get rid of these drive methods over here, and I go my red Ferrari dot paint purple, and if I call this, we're going to walk through the process of how Java kind of deals with this whole action here. And so we are calling this on our red Ferrari. So this is our 812 GTS 2023 Ferrari that is colored red. And so now when we take the car that's stored in the my red Ferrari container and we call the paint purple method on it, it's going to go over to the paint purple method over here, or this action, and it's going to run all of the code here in the method body. And so what it's going to do is it's going to take the color and it's going to set it equal to purple. Now, remember at the beginning of this lesson, the really important point that I wanted to get across was that the objects that are stored here within this is the object, and the object here that is stored in the my red Ferrari container here, these objects here are just an assembly here of basically the instance variables of these containers. And so because our methods here are actions that our objects can perform, they have access to the variables that make up what a car object is. And so we are taking the color container that is stored with the my red Ferrari car, and we are reassigning the value within that container to purple. And so when we call this method, we reassign this color container here to now purple. And so if we go and we print out my red Ferrari, and we print out, oops, I have to put it in a print statement, sys out my red Ferrari dot color, then what we get is we get the color purple. Now, you may not realize it at the moment, but this is an absolute huge development for our ability to program here, because if we wanted to go through and we wanted to modify all of the characteristics of a car here without generating a new object, we'd have to go through and we'd have to go like mygreenferrari.brand equals, and we'd have to assign a value, and we'd have to go through and we'd have to do that every single time we wanted to do this. But now what we can do is we can do all of that here within a method. And right now, this paint purple method is very simple. It's only a single line. But when you have methods that start to be 30 lines, 50 lines, even a couple hundred lines, now we can simplify an entire task into a very repeatable process that can alter the state of these cars. We can change what's going on with individual cars and have them carry out actions and influence themselves and do all sorts of things that allow us to represent real world relationships and actions. So before we dig too far into this idea of modifying the state of our objects, I also want to remind you that, or inform you that, we can also read out the state of our objects here. And so in order to do this, what we're going to do is we're going to go back over to our lesson 4 main file, and we're going to copy out this print statement that we used over here in our main file here to print out the state of the cars and to read out like the color of the model in a nice organized way. And so we're going to use that print statement there, and we're going to combine it with a method here. And so remember that ultimately a method like our print state method that we're going to define here is just a block of code that will run when a method is called. It represents all these things like actions and everything like that. But ultimately this is ultimately what it is a block of code that will run when a method is called. And so if we go through and we create a void method because we're not going to send information outward, and we name it print state, and we put empty parentheses because we aren't sending information into our method. And then here within our method body, we add this print statement. What we can do here is we can go through, and I'm going to remove the milder Ferrari.color because we're not accessing this through a container. In lesson 4, we had to access like the color and the models via the containers. Here, we don't need to do that, and I'll explain why here in a sec once I get all of these errors here to go away. And get over here and remove it here as well. So the reason that we can access all of these pieces of information, like the color, the model, the brand, and the year produced of our car like this, is because that these methods are actions that are being performed on car objects. So if I go back over to our main.java file and I take our my red Ferrari container and the car that is thus stored inside that container, and then I print out I call the print state method, then what we see here is it prints out the state of the object. And the reason it does this is because this method here is an action that acts on a my red Ferrari object. And remember, this is like the third or fourth time that I brought this up, that these car objects are just like an assembly of the instance variables. They are one in the same. A car object is the same as these 4 different instance variables wrapped together. And so because we know that a car object is calling this print state method, we have access to all of those variables that we know are going to be tied to that object. And we access them by name because that's what we told Java each of these car objects would have. We told Java that every time we create a new car object, it's going to have to basically set aside a place in memory, and it's going to have to create 4 variables that are tied to that object. And every single one of these objects has these same 4 similarly named containers, and they can have their own unique versions of these containers stored in different locations, but they all have the same unique name. That's the reason we set up this blueprint. And because we're telling Java that, hey, every car object is going to have these 4 instance variables, we can confidently say here in one of our methods, because it is a car object that is going to call this print state method, we can confidently say that that car that's calling this method here is going to have these same 4 instance variables because those variables or those containers were set up when those cars that are calling these methods now were created. And so that's why this print state method here works. Now, with an understanding of why these methods work and why we're able to do the things that we're able to do with this, what it introduces is this wonderful, wonderful idea of being able to reuse code. So in the last lesson, we in our main.java file, if I bring up the main.java file from lesson 4 and you can tell the difference here between the lesson 4 and the lesson 5 here by this modifier here, this little piece of text. But to print out the state of two cars, we needed two of these print statements. And every time we need to print out some piece of information like this, what we'd have to do is we'd have to copy and paste this, and we'd have to create another one of these ugly lines of code every single time we wanted to print this out. And look at how messy this file is already. It's really hard to read, and there's just a lot going on. So instead, what we can do is we can turn this task of printing out all this information into our single method here. And now every time that we want to perform this entire task, because once again, a method is also just a block of code that will run when a method is called. That is at its core what a method is. And because that's what it is, we can simplify that entire task down to just calling this print state method. It's just going to call all of the things, all of the instructions here to print out the state of our object. And I'll close the main file, or the main.java file here from lesson 4, so we don't get confused here. But if we go down here and I go my green Ferrari.print state and I run it, well, now we get the red car, or the red 812 GTS, and the green 812 GTS. And we've simplified that entire process down to, instead of having that massive, nasty print statement there, we write out that nasty print statement here once, and then we just call this much simpler method every time we want to perform this action. And it introduces this wonderful idea of reusable code, which we as programmers will very, very quickly learn to love, because coding loses so much of its fun when you are just stuck there writing out the most tedious things. You want to program, you want to use your brain, you want to problem solve. You don't want to be sitting here writing out words for half an hour because you set something up poorly. Now, as nerdy as all of this sounds here, when I say reusable code, yippee, there's a reason I say all of this. And this is because reusable code makes our lives so much easier. Like you don't even understand. Like you are at the very beginning of your journey. And right now you're in your infancy. You're learning how to just do the basics. But as you go along, as you learn how to do all the basic things, one of the most important things that you can do is write reusable code. Because when you write reusable code, it makes your code so much more readable. When you have to go through like a massive program and you have to figure out what's going on, you want that code to be understandable. Using reusable code in a format like this makes your code way more easy to understand. That's the first reason to do any of this. The second reason is because it saves you so much time. One of I mean, we have 6 weeks in FRC to program an entire robot. That may sound like a lot of time, but when we are trying to go through and we're trying to fix problems and bugs within all of this code, you start to realize that that's not a lot of time. We don't get time to test on the robot. We don't get time to do a lot of things that we want to do. Time is extremely valuable. And when we have to go through and spend a lot of time copy and pasting code, writing a bunch of unnecessary code to do very simple things, you start to waste a lot of time. And that's something that we just cannot afford. And this is why reusable code just makes me happy, is because it saves me time. It saves me from banging my head up against the wall, trying to refactor things down the line because I tried to make it too simple. And yes, there is a point when you can like go overboard and make things too reusable, where now it takes even more time than doing it a more simpler way. But the as you learn in your coding journey here, you will quickly learn that a lot of the things that you will be learning to do is making your code reusable. And that's one of the biggest ideas and one of the biggest things that you want to learn here with programming. Now, getting over that rant on reusable code here, I want to now demonstrate, or I want to jump back over to the idea of modifying the information of our car here. And so with this image over here, I want to go through and I want to create a new method that's going to remodel our car into a yellow buggy. And so what we're going to do, we're going to start up by creating a void method, and we're basically going to take this paint purple method and we're going to take it to the extreme where we change all of the characteristics of our car. So we're going to name it void and we're going to call it remodel to buggy, buggy, and then empty parentheses because it's not going to take in any information. And then we're going to go through and for the same reasons that we could access the color, the model, the brand, and the year produced by these names specifically, we are going to modify those specific containers to now hold different information. And in this case, we're going to make it so any car that calls this remodel to buggy method is going to have all of its instance variables, its brand, model, year produced, and color, rewritten to these values here instead. So it's going to take the model equals beetle, and then it's going to take the year produced equals 1999, and it's going to have the make be assigned to Volkswagen, the brand. The brand equals Volkswagen, and then the color equals god awful yellow. And so now whenever this method is called, it's going to reassign each of these containers here with these specific pieces of information. We can actually verify that using this print statement method over here. So if we come over here and if I delete this statement here, and we print out the state of our red Ferrari, we'll first see what that is. So it prints out, this is a red 812 GTS Ferrari produced in 2023. And then on that red Ferrari object, we call the what did we call it? Come back over here. The remodel to buggy method, remodel to buggy, and then we print the my red Ferrari again, and we print out the state of it. Then we now see that we went from a red 812 GTS Ferrari produced in 2023 to a god-awful yellow Beetle Volkswagen produced in 1999. And once again, I can also prove to you that for like the fifth time that if I print out the state of the green Ferrari, or the car stored in the green Ferrari here, that it'll still be the green Ferrari, because these instance variables are like the instance variables here have like different versions to them for each different object. They each have their own like unique versions of it. And so the my red Ferrari car, the car that's created up here, has a brand, model, year produced, and color that's stored with the memory address of this specific car. And Java is going to assign that memory address. We don't choose that memory address, but Java is going to assign it. But with that memory address, it's going to have those 4 instance variables that can be accessed via these names. But with this one, with this car that's stored at a different memory address, it's going to have its own version of these instance variables, which will still be accessible by these same names, but they'll store the values tied with the other containers stored at that same memory address here, and won't have the same value as the one stored here. And so if I print out the state of my green Ferrari here, it will still hold the unique state of the green Ferrari that was assigned up here. Now, something I'd like to really quickly point out here before we move on here is that when we call this print statement, what you'll notice here is that when we print out the state of my red Ferrari, we get this statement that says this is a god-awful yellow Beetle Volkswagen produced in 1999. And at first you might say that, oh, this is exactly what we wanted to happen, and it is. But now we run into the issue of this container, the name of this container, my red Ferrari, no longer represents what's stored here within the container. And so at some points here in our program, this might create a problem down the line where we might be expecting a red Ferrari and we end up with a yellow Beetle. So what we'd want to do if this were a larger program is try to come up with some better name here for our container here to represent all of the different potential states that could be stored, or the different types of cars that could be stored in this container. We want our container to, during its entire lifetime, we want it to represent all of the information that could be potentially stored inside of it. So before we reach the end of this lesson, I want to talk about two things real quickly. The first is this idea that we can put methods inside of methods. Remember that a method is just once again, a block of code that will run when a method is called. And so what we could do is, because they're just basically a set of instructions that will be run when it's called, we can put a set of instructions within another set of instructions. So within the remodel to buggy method here, I can also add the print state method here, so that anytime I go through and I call my red Ferrari dot print, dot remodel to buggy, it now, in addition to not only remodeling it, also prints out the state of the object. And the way you can think of this as like behaving is that, okay, so Java knows that you are calling this action from the my red Ferrari object, and so it's going to go over to our remodel to buggy method, and it's going to use that method with the context that all of this information here is tied to the car that's calling it, in this case the my red Ferrari. So the model, the year produced, the brand, the color, those are all tied to my red Ferrari. But when we call this print state method, because this is also an action that a car can perform, Java is going to infer that you are still using this my red Ferrari object, and so that you can now also call the print state method on that my red Ferrari. So it's essentially acting like my red Ferrari print state. And this doesn't work because this class has no knowledge of the name of the container, but this is what Java does in the background. When you call this print state method, it is inferring that you want this method to be called from your my red Ferrari object. And so it's basically then just going to go through and run all of these instructions from the context that you are calling that instruction from the my red Ferrari object. Now, there are two things here that I still want to discuss here in this video. The first of which is parameters, and this is something we've already seen here in our constructor. This list here is a list of parameters that we pass into our constructor when we want to create a car object. And so we can do the same thing with methods, where we create these temporary containers that can store in information from other parts of our file. That way we can then use them here within our method here. So if I come down here and I write out a method that returns void, it doesn't send any information outward, and we say print out string, and within the parentheses here, we add a string to print out. So we're going to create a container here that's going to accept some argument from another location in our file. And so this container is going to be able to store information from other places in our file. And we're going to name it string to print, and then we're going to put our curly braces. And what we can do here is we can do system.out.println, and we can print out string to print. And so what this is going to do is, it's when we call this method here from our car object, it will require us to pass in an object or a string to be stored in this string to print container. And then here within this method, when it runs the set of instructions for this method, when it goes to print out the value here, it's going to print out whatever is stored in our string to print container that we passed in up here. And so what that's going to look like is if we come over to main.java and I go my red Ferrari dot print out string, and we pass in a string saying this is a string, then what happens is this just gets printed out on our screen here. And so by passing in this string here in this file, we store it here within this string to print container local to this method here, where then we can use the information that we passed into this container here to be able to print that string out. The other point of significance here with being able to pass in parameters here is that also, like the constructor, we can pass in additional pieces of information which can be separated out via a comma. So if we put the comma there and then we list a new type of container and the name of that container, say we call it int to print, and then we concatenate that on to whatever is stored in the string to print container. So int to print, oops, print. Now we would have to change our implementation of our printout method here because there is no matching method with only one parameter or one argument being passed in. And so now we have to add our second argument to be able to use this method, in which case we have to pass in an integer to print as well, in addition to our string. So if we come back over here, and we go to the end of our string here, then we put a comma and we pass in the integer that we want to send over. And so if we run this, then we get that integer concatenated onto the string as well. The last thing here that I want to discuss in this video here is the return type. We just discussed the parameters here and how they allow us to send information into a method, but what I want to talk about is how to send information back out of a method, and that is through the return type. So far in all of our examples, we've listed the return type as void, indicating we don't want to send out information. But what we could do instead is we could list it as anything but void. And so if I go over here, and the goal of this method I'm about to write is to return a string that represents the state of our object. So instead of printing it out down to the console down here, it's going to take this string here that represents our state, and it's going to send it off over to another file. And so what that's going to look like is we're going to come down here and we're going to write out a return type of string. So our method is going to be required to send out some string representing the state of our object. And so we're going to call that method then, remember that the next part is the method name. We're going to call that method return state. And so this is going to return the state of our car here represented as a string. And then we're going to put our curly braces to represent like our instructions here. And then within our instructions, what we're going to need is the return keyword. And so we type out the word return, and whatever comes after this return keyword is going to be what gets sent out at the end of our instructions. But we have to be careful because the return keyword should only ever go at the end of a method. If we had other sets of instructions here, that would be necessary to make our method run here. These would all have to run before we return out information, because when the way Java works is that when we send information back out, it only happens at the end of our method. And so at the end of our method, since we don't have any other instructions here, we're going to type out return, and then we're going to return the type of information that we want to send out. And in this case, we're going to copy the string that we were printing out here in our print state method, and we are instead going to return this string. And this entire thing here is a string, once again, due to string concatenation, where every time you use the plus operator between a string and anything that's not a string, it's going to go through and turn this like entire statement here into a string, and then it's going to do that again until this entire thing becomes a string. And also, once again, the color, the model, the brand, and the year produced are all accessible containers to our method because this method is going to be called from our car object. And so because it's the car object that is calling this action or this method, we directly have access to the containers that go along with that car object. And that's why we can reference them by like the instance variable names and everything. And I explained that earlier, so if you're still confused about that, go back and rewind and listen to when I wrote out this print state method and the paint purple method. But now if we come over here, now that we've got the return type listed as a string and we're returning the the string representing the state of our object, we can come over here, and what we can do with this is we can store the result of this method here inside of another container. And so we could go string container, and within this container we can store my red Ferrari dot return state. And so when we call this method here, remember that a method is a block of code that will run when a method is called. So it's going to run all the instructions, and then at the very end of the method, after it's run all of the other instructions related to this method, it's going to return this specific piece of information. And by return, what I mean is it's going to return this information here to wherever the method was called. Our return state method is called here in the main file. So that information is going to be sent from our car.java file over to our main file here. And so then the string representing the state of our object is going to be returned here, and then we assign that state into the string container called string container here, and we do that via the assignment operator here. And so if we were to print out what is now stored in the string container, so we go sysout string container, then it's going to print out, in theory, the state of our object, because that's what was returned here. That was what was stored in the string container, and that's what we are now printing out here in this statement here. So if we run it, we get the state of our car. I would also like to point out here that we don't necessarily have to store this string here that gets returned here in a container. What you can essentially treat this as is just some string. It's a string that exists somewhere here in our code, and at some point it's going to be replaced with some string here. And so because this could be the equivalently treated as just a string, we could just directly print out the value here that's returned from that method. So if we erase all of that, what we can do is we can print out my red Ferrari dot return state. And because this thing returns a string, when we go and we call our print statements here on a string, it's going to just print it out as we would normally expect it, giving us the same result. So that is going to bring us to the end of today's lesson. For reference, the lesson here and the exercise are going to be separated into separate videos just because these are already getting to be a little on the longer side. So I'm going to have another video here after this walking through how to do the exercise. That's also on one of the longer sides here for problems to solve. As always, I encourage you to watch the quiz, go back, review, and make sure that you understand the content of this lesson before moving on, because this is some of the most important content that we're going to cover, is this introduction into object-oriented programming here. And so I encourage you to go back, take the quiz, and we'll kind of go from there. But as always, thank you for watching, and I guess we'll see you in the next one. Peace.